Finding the area of a part of a circle is the exact same way we found the arc length of a circle. We're going to find the area of the circle, so quick refresher, that's pi times the radius squared. So if the radius of this again was 6, the area would equal pi times 6 squared, which we're going to leave in exact terms as 36 pi. But if I want to know the area of a sector is nothing more than a piece of the circle, or a piece of pie, a lot of people think of it. So a sector is just a section of the circle. And to find the area of a sector, we're again going to find the fraction of the circle that we have. So fraction of the circle multiplied by the total area. Because if the area is 36 pi and we have half the circle, well then that's going to be 18 pi. If we have 36 pi and we have 1/4 of the circle, then the area of the sector is going to be 9 pi. So let's use the same radius as 6, but let's say the angle here is 60 degrees. We know the area of this circle is going to be pi times 6 squared, which is 36 pi. But if that central angle is 60 degrees, then so is the arc that's being intercepted. So again, if we have 60 degrees out of a possible 360 in the circle, we have 1/6 of the circle being cut off here. So if we have 1/6 of the circle being cut off, that means we have 1/6 of the area. So to find the area of that sector, we're going to say 1/6 multiplied by the total area of 36 pi, which is 6 pi. And again, we're going to leave that in exact terms. So the area of this sector that I have shaded in here is 6 pi. Just like finding the arc length, except we're taking the fraction times the area because we want the area of the sector, or the section of the circle. So let's look at one more example. New radius, new angle. Let's say that the radius of this circle is 8, but this time you have a 36 degree angle. Well, we know that the area of the entire circle is pi times the radius squared, which in this case would be 64 pi. We need to know what fraction of the circle are we cutting off, because we're only interested in this sector of the circle, or this section. We have 36 degrees out of a possible 360 degrees, which is exactly 1/10 of the circle. If we have one piece out of 10 of that circle, then we can say 1/10 of the 64 pi is going to equal 64 pi over 10. Now this we can reduce. 64 and 10 both would be divided evenly by 2, so we're going to say this is actually 32 pi over 5, and we can't reduce any farther than that. This is the exact area of the sector of that circle. Now some of you don't like leaving things in exact terms, but this is how I want you to leave it. If for some reason you punch this out on your calculator and you actually divide by 5 the 3 pi, you're going to get approximately 20.096. But this is an approximation. I want the exact term, so please leave it as 32 pi over 5. The only other way I might ask this question is if I give you a circle and I say, well, find the area of the shaded region. So let's say this sector right here is shaded in, and this sector over here is also shaded in. We just have to find the area of 2 sectors instead of 1. So I need to give you some information. Let's say that this central angle right here is 120. And let's say the radius is 10. Well, if I can find the fraction of the circle that I have, then I can figure out how much of the area is being shaded. So let's just start by finding the area of the circle. The total area of the circle would be pi times the radius of 10 squared, which is 100 pi. But I need to know what is this central angle that's being cut off. Well, that angle is a linear pair with the 120, and linear pairs have to add up to 180, so that central angle is 60, which means this arc is 60. But that 60 degrees is also vertical to this angle, so that's also 60, which means this arc is 60. So a couple different ways you can think about it. I'm going to do it this way. If I have 60 degrees out of 360, that's exactly 1/6 of the circle. So 1/6 of 100 pi is going to be 100 pi over 6. Now again, both of those would reduce, so this would reduce to 50 pi over 3. Now the 50 pi over 3 just represents the area of this one sector that I have outlined in black. I could then find the area of the other sector and add them together, but this sector over here is the exact same sector, 1/6 of the circle. So I can just multiply this 50 pi over 3 times 2, which is going to end up equaling 100 pi over 3 as a total area of my shaded section. And that's how we use the area of a circle with the fraction of the degrees to find the area of a sector.